My name is Kainton the Tech Pro, and today we are going to be talking about heteroscedasticity. Heteroscedasticity. So that is the name of the term, and it's a very important data science term. Sometimes in a quiz, you may encounter this problem, or even some interviews. Some interviewers can really be crazy, and you will be asked to explain this term. So I'm not trying to derive all the formula or the technical terms, all the notations completely. I just want you to understand the concept and be able to explain it in your own words. So remember to subscribe so that you can get answers to many more data science questions. Remember, I've also explained this in my website, as you can see. So now I'm just giving a clearer explanation and also to give some of the notations in this case. So now heteroscedasticity refers to a systematic change in the spread of the error term over a range of measured values. Another definition is that it is a linear correlation between two or more predictor variables. So this second definition actually doesn't tell us much about it. So the problem with heteroscedasticity is that in regression, which is its ordinary least square, all the residuals are taken from a population with constant variance. Therefore, the residual are also expected to have a constant variance such that I'm going to write. So what is expected is that we have variance in the error is equal to the same as that in the population. So to illustrate how it exactly works, let me just take a simple data plot, a simple data set, and plot it and then show you what we are saying. So let's say in a simple graph like this, what is this? So in a simple graph like this, all right? So we performed regression and we have data points in different places. Let's say we have these 4 data points, right? And we fit a regression line through this data point. Take a green one. We'll fit a regression line, if I can, okay. And now we have error times that are measured. I'm using another color this time. So we have error measured here, we have here, and we have here. All right. So now, if you continue to measure these error time, it's expected that the variance in the error is going to be constant. So if you measure for this region, let me use white. If you measure the variance for this region, it should also be the same as for this region. But let's assume that the more you are going, the more the error term is increasing. So let's say we have error term here, have data point here, we have data point here, we have data point here, we have data point here. So in this case, we have a situation whereby the error is actually, the variation in the error is spreading out across the data point. So you can see it's actually spreading out. So the challenge is the situation whereby you can't really predict the actual variance of the error in this data set. So this is because the assumption fails in the case of heteroscedasticity, and there is unequal scatter as shown below. So if you take a look at this case, you can see that the spread is actually unwildly in this case, because the more the line continues to move, the more you have a scatter. So you can't actually make an accurate prediction. So the question is, how do we handle the situation in situation of heteroscedasticity? So although that is not exactly the key on this particular question, but I would like to just mention it. So one way is to handle this problem is to transform the response function using concave function such as log y or y. So instead of to model, let's say, function of x is equal to y, which is equal to, let's say, beta 0 plus beta 1x. So you can now have something like log y. So you simply take the logarithm, and hopefully it could kind of restrict it to make it a bit constant along the line. Or you can take something like root y. Okay, so this is what heteroscedasticity is all about. So I would like to thank you for viewing. I'd also like to remind you, take some time to read through. Make sure you be able to explain it in your own words. And in the next question, we are now going to discuss what is sensitivity analysis.